Now, before we go any further, I want to reiterate that you cannot solve a quadratic inequality the way you solve a linear inequality. So here's, in fact, the inequality that we just did in the previous example. So suppose you had this. It's true to say this next step. You can go ahead and factor the quadratic expression into the product of two binomials. However, this is false. And I'll tell you why that's false. You have two numbers being multiplied together to make a negative. So this is saying something times something is negative. Well, the only way that happens is if one of these is positive and the other is negative, or if the first one's negative and the other one's positive. The only way that you get a negative as the result is if the signs are opposite on the two things being multiplied. Well, look what this says here. I take a negative and a negative, so this is negative and this is negative, and I multiply them together and I make a negative. That's silly. There is a way to write this down, and I'll try to do it up here. And I hope to convince you that it's so complicated that only people who are incredibly crazy would want to attempt to do it. If you go from this correct step, you can say that x plus 3 is negative and x plus 4 is positive, so it's bigger than 0. So you can say that, or x plus 3 is positive and x plus 4 is negative. So if you want to do this algebraically, you have to solve this doubly compound inequality. I'm not doing it with you. It's just too much work, and it's too fraught with possibilities of error. So on a test, if you write this, you fundamentally don't understand what inequality means, because you're saying that a negative times a negative makes a negative. So don't do it this way on a test. We have another example to work here. Now I look at that, and the first thing I see is, hey, there's a common factor of 2 in all three terms. The first thing I'm going to do is divide both sides by 2. You can do that whether it's inequality or an equation. Then I'm going to pass to the equation. So 2x squared plus 5 equals 3x. 2x squared minus 3x plus 5 equals 0. And I look at that for a few seconds. Let's see, 2 and 1. Give it a quick attempt to factor. So a 2x and an x. The 5 would probably have to go there, and a 1 there. If I make that a negative and a positive, then FOIL check 2x squared plus 5x minus 2x. I got the signs wrong. So 2x minus 5x plus 1 equals 0. So you get a minus 5x plus a 2x is a minus 3x. Good. So now if that had not worked, I would have used the quadratic equation on it. So I've got a factored form equal to 0, so I can solve. Actually, you need to put the or between those to make this a correct statement. So let's see, 2x equals 5, x equals 5 halves, x equals negative 1. And then a quick sketch that'll fit up here. Negative 1 is about there, 5 halves is positive, so it's greater than it, so it's to the right. I look at the the quadratic that's here, either one of these, a equals 2, that's bigger than 0, so we open up. So I'm drawing a parabola-like shape opening up. Okay, so if I rewrite this like this, then my inequality says that I'm less than 0. So that means I want to be under the x-axis. So where is this graph under the x-axis? Well, this is graph under the x-axis. These are the x's that make it happen. These are my solution. I'm under, I'm not on, so I have to exclude that point and that point. So there's the graph of my solution, and I can just take that graph down here, and I can translate it as an interval -1 to 5/2 exclusively. That's an interval, or I could say -1 is less than x is less than 5/2. So depending on how you have to write the solution, or if on a test I don't specify, do one or the other.